Good day, viewers. Welcome to Franchise TV. Keep watching, keep learning. In this particular video, I'll be letting out some certain principles on how to perform well in chemistry practical examination GCE 2022. But before I proceed, I would like to introduce myself. I'm Mr. Francis, and I'll be taking us through the journey of chemistry practical for Waec GCE. Chemistry practical for Waec GCE. Now, when we are talking about Waec GCE, chemistry practical in Waec GCE is quite different from the chemistry practical for your school exam, because in Waec GCE, the chemistry practical is actually alternative to practical. The chemistry practical in Waec GCE is actually alternative to practical. In this particular section, you are not expected to perform any experiments. In Waec GCE, you are not expected to perform any experiments. The information will be provided to the candidate. Nobody is expecting you to go to the lab to perform experiment of titration. Nobody is expecting you to go to the lab to perform experiment on salt analysis. Because of that, I would, in this particular video, I'll be letting out some certain principles, some certain guidelines in order to perform in your Waec GCE chemistry examination. I will endeavor that my viewers should kindly jot out some certain principles, just some important information out, because they are very important in passing this examination. Now, when we are talking about chemistry practical for your GCE, the chemistry practical is divided into three sections. We have the titration experiment, we have the salt analysis, and the third aspect happens to be general knowledge, your general knowledge about chemistry. Now, in your Waec GCE, knowing fully well that you are not performing any practical, there are some certain things the examiner will decide to ask. Number one, they will provide you with an information on the table, provide you with your titration value, your first titration, second titration, third titration. They can ask you to what indicate the errors present on the table. Apart from that, again, they can also ask you what is the choice of indicator that is being used in this particular experiment. For you to answer that question, it is very simple. The only thing you just need to know is to know the acid that is being given in the question, and also know the base given in the question. If the acid in the question happens to be a strong acid, examples of strong acid are hydrogen chloride, HNO3, and H2SO4. And why are they referred to as strong acid? They are called strong acid because they are ionized completely in water. Anytime they dissolve in water, they are ionized completely. That's why they are referred to as strong acid. If in your question you have been provided with strong acid and you are also provided with a strong base, in your titration experiment, you expected to make use of any indicator, because the titration is between a strong acid and a strong base. Now, what are the indicators you expected to? You can make use of methyl orange, you can make use of methyl red, and you can also make use of ferrophthalate. Now, when we are talking about indicators, indicators are weak organic acid that change color according to hydrogen ion concentration. Now, for example, if in the question two you have been given a strong acid, and in the question a strong base, the strong acid is titrated against a weak base, the strong acid is titrated against a weak base. In that experiment, you expected to use what? Methyl orange. Methyl orange is suitable when you have a strong acid titrating against a weak base. But if you have a strong base titrated against a weak acid, a strong base, you are titrating a strong base against a weak acid, you are expected to use what? Ferrophthalate. But in a situation when you have a weak acid and a weak base, no suitable indicator for the experiment, no suitable indicator for the experiment. As I proceed, I will give examples of strong acid, strong base, weak acid, and weak base, because it will be very helpful. Anytime you are doing your titration experiment, number one, look at the choice of acid, look at the choice of base. The choice of acid and the choice of base will determine the indicator that will be what suitable. Now before I proceed again, I would like to mention some certain areas that are also very but helpful. Now when you are talking about meteorage, if you are using meteorage as your indicator, your endpoint, what will be the colour, that can be another question. What will be the colour of meteorage at the end of the reaction? If you are titrating your acid, strong acid and your strong base, and you are making use of what meteorage, what will be the endpoint? What will be the coloration at the end of the reaction? For meteorage, the endpoint for titration and for neutralization to actually occur, that point at which neutralization occur, there will be formation of what orange colour for your what meteorage. There will be what formation of what orange colour. But if it happens to be phenolphthalein, when you titrate, remember that phenolphthalein is actually suitable when you titrate a strong base against a weak acid, and at the end of the reaction, the end point at the end of the reaction will be what formation of what pink colour. That can also be another question. Another question that can actually be asked for this your titration experiment, remember that you are not practicalizing this experiment, but there are some certain questions they can actually ask you. What are the precautions that are being put in place when performing your titration experiment? Because of that, these are some of the likely questions that the examiner will decide to find out. What are the precautions when performing a titration experiment? Number one, you can actually make them to understand that when you are putting your base, that you ensure that your conical flask is actually rinsed with base before pipetting your base into the flask. That's number one. Number two, you can also tell them that when they are introducing your indicator, that you introduce 2 or 3 drops of what indicator. Those are some of the precautions that we actually put, that you were what putting in place when performing your titration experiment. You can also tell them when you are measuring your acid, you ensure that the funnel was removed before performing your titration experiment. Now the next one again, you can also tell them that when you are performing your titration experiment, you avoid what air bubbles when making use of your pipette. Now in today's video, I'll be showing you an example of a table and pointing out the errors present in that particular table. I'll be showing you an example of a table, and I'll also be pointing out the errors present in that particular table. Now in this particular table, they can decide to ask us this particular question, that we should identify the errors present on this particular table. Remember that this table will be provided in the examination question, but the question in this, from the question they ask us to answer in this particular table, is to identify the error present on this particular reading. Identify the errors present in this particular reading. Number one, the first error on this table is number one, the indicator used for this particular experiment was not specified. That is number one error. The indicator used for the titration experiment. Remember that your titration experiment is an experiment that involve acid and base, and there is also present of indicator. Anytime you are performing your titration experiment, 3 materials must be available. Number one, acid. Number two, base. And number three, indicator. In this particular table, the indicator used was not specified. Automatically, the reading does not really make what, there is no adequate information, the reading does not make sense. Because of that, that is number one error. Number two, the volume of pipette used in this particular experiment was not also indicated. The volume of the pipette, whether it is 20 centimeter or 25 centimeter cube, the volume of the pipette was not indicated. That's number two error. Number three, the burette reading, the unit of the burette reading was not also indicated, whether it is measured in centimeter cube or whether it is measured in dm cube. Nobody knows, because the unit of the reading was not what indicated. And apart from that too, some values on the table happens some values on the table happens to be in 2 decimal places, while some are not in 2 decimal places. And according to our titration experiment, anytime you are recording your values, the value should be in 2 decimal places. Like 28 is not in 2 decimal places. 3.2 not in two decimal places, 24.8 not in two decimal places. Those are some of the errors present on this particular table. The next one, for the average titral value, the average volume of acid used, the calculation of the average titral value happens to be wrong. Why? Now when we are calculating average titral value, we only make use of what? Consis ten t reading. We make use of what? Consis ten t reading. Now the next question is, when is a reading said to be consis ten t? A reading is said to be consis ten t when the difference between the two readings is less or equal to 0.20. I will repeat. Now the average titral value happens to be wrong. Why? Because the reading, when we are calculating our average titral value, we did not make use of what? Consis ten t value. When is a reading said to be consis ten t? A reading is said to be consis ten t when the difference between the two readings is lesser than or equal to what? The 0.20. But when you look at this reading, 24.70 and 24.80, they happens to be consis ten t because the difference between them is what? 0.10. But when we look at 25.80 and 24.70, the difference between them is 1.10 centimeter cube. Because of that, these two readings are not consis ten t. This reading and this reading, the difference between this and this is 1.00. Because of that, when we are calculating our average titral value, it is expected of us to make use of what? Consis ten t values. Values that the difference between them is lesser than or equals to what? 0.20. And from as a result of that, our average titral value happens to be very wrong. The average titral value in this particular reading happens to be very wrong, because according to the titration experiment, you are only expected to use values that are consis ten t. That means if you are looking for our titration, your average titral value in this particular question, we have 24.70 plus 24.80 divided by 2. But in this particular question, there is an error in our average titral value. And not only that, the unit of the average titral value too was not what? Indicated. Now the next question from this aspect again, they can decide to ask us, what is the choice of indicator used in this particular acid? They provided us with the acid. The acid in the question is hydrogen chloride, while the base in the question is sodium triisocarbonate 4. Sodium triisocarbonate 4. And remember that our choice of indicator is actually dependent on the nature of the acid and the nature of the base. If the acid happens to be a strong acid, if we have a strong acid versus strong base, in this titration experiment, we are expected to use what? Any what? Indicator. Anytime you have a strong acid and a strong base, you are expected to make use of what? Any indicator. Examples of strong acid are hydrogen chloride, HNO3, hydrogen triisonitrate 5, H2SO4, hydrogen tetraisosulfate 6. And examples of strong base are sodium hydroxide, potassium hydroxide, and calcium hydroxide. All these are examples of what? Strong base. Anytime we have a strong base and a strong acid, you can make use of what? Any indicator. But if the reaction happens to be between a strong base and a weak acid, 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 we are expected to make use of what? Phenolphthalein. Now examples of strong base are sodium hydroxide, I've stated them before, potassium hydroxide, calcium hydroxide. All these are examples of what? Strong base. Now when we are talking about weak acid, H3PO4, H2CO3, H2SO3, all these are examples of what? Weak acid. Ethanoic acid, CH3COH. All these are examples of what? Weak acid. Anytime you have strong base and weak acid, you can make use of what? Phenolphthalein. That is the only what? Suitable indicator. They can ask you why. Why are you making use of phenolphthalein? because it is a reaction between a strong base and a weak acid. Now the next one, when you have a weak acid and a weak base, weak acid and a weak base, weak acid example ethanoic acid H3PO4, H2SO3, ammonia happens to be a weak base. When you have a reaction like this, magnesium hydroxide weak base, Na2CO3 weak base. When you have a reaction between a weak acid and a weak base, no suitable what indicator, no suitable what indicator. But if the reaction happens to be between a strong acid and a weak base, strong acid and a weak base, you make use of what meteorange. They can ask you in this particular reaction now, the acid in the question is hydrogen chloride, which happens to be a strong acid, and Na2CO3, which happens to be a weak base. Automatically the indicator that will be used in this particular experiment will be meteorange, and they can decide to ask why we make use of meteorange, because the reaction is between a strong acid and a weak base. Another question that can actually come out from this table, they can decide to ask you another question. Why do you decide to perform your experiment up to 3 times? Why do you decide to perform your experiment up to 3 times? Now the answer is actually very straightforward. Now this one we are performing this experiment up to 3 times in order for us to get what consis ten t values. We want to get what consis ten t value. That's why we are what repeating the experiment in order for us to get a consis ten t reading. Anytime you are calculating your titral value, remember that you are only going to make use of values that are consis ten t, and when is a value set to be consis ten t? When the difference between them is lesser than or equals to 0.20. In the next video, I will be solving some likely questions in your titration experiment. I will advise my viewers to subscribe on this channel, click on the notification button, ask question in order for you to have proper understanding of this particular concept.